In this video we are going to show how to consume XCP-ng latest 8.2 LTSR release with CloudStack, how to configure networking on the XCP-ng side in order to be consumed in CloudStack the way we want it. So this is going to be basically a demo of how to do things in a specific way, depending on what we want to actually do. So let me first show you a diagram of how our network infrastructure is meant to look. This is basically our environment. So just to zoom this a little bit, we have a management server, we have a dedicated NFS server. Now obviously this is not a production environment, this is just for demo purposes, and we have two nodes which are XCP-ng 8.2 version. A thing which I added but is kind of less relevant in this diagram, and you can pretty much forget about it, are the specific IPs, networks, VLANs for the guest and public and so on. This is all of a less importance for our demo. What is important is to realize that our hypervisor nodes have two network cards. The first network card of the both hypervisor nodes being connected to what we will call the network 0 or the management network. That would be probably a network to which you SSH after you access your physical environment, and this is where the traffic flows between the management server, NFS server, and the hypervisor nodes. At the same time, we have a second network card in both hypervisor nodes. This is the NIC number 2, and it's actually connected to a switch port. In my case, it's all virtual and nested, but in physical world, it would be connected again to a switch ports which are in trunked mode. And we have certain set of VLANs that we are going to use for the guest traffic, or for the guest VLANs basically. This guest VLAN should be in blue actually, my bad over here, but anyway. And we have a public VLAN which further eventually will route the traffic to the internet. So for example, you can download templates from internet and so on. Or your VMs running on those hypervisors via virtual routers can access internet really. So this is the short diagram. Now how it looks with CloudStack. Here I already have my zone set up and it's currently disabled. I have two physical networks basically which to be honest, this was already pre-configured environment where I deleted the cluster, the hosts, and the primary storage for that cluster. So it's all empty. As you can see, we have our pod created and our zone created and the secondary storage defined. So basically we are here simulating in this demo. Imagine that you already have running CloudStack, you want to add XCP-ng. So how do you do that? You want to add a new cluster and a storage for that cluster. So I've chosen to basically reinstall my two hypervisor nodes. As I mentioned, these are nested on top of VMware, but in your case it could be physical nodes. So we will boot from the CD-ROM and both nodes, and we will try to install it SAP. Just for the sake of information, this is really not relevant, but these are free CPUs, hypervisor with 8 GB of RAM for demo purposes and a single 80 gigabyte disk. You can see we have two network adapters, which is basically what I mentioned over here. We have network card number 1 and network card number 2 connected to different VLANs or switches, potentially depending on your environment. But here we are using untagged traffic for the management and storage, or untagged VLAN basically for the management and storage, while here we are actually using as expected tagged VLANs in the certain range for both the guest and public. All right, let's try to rewind this a little bit because this is pretty standard installation where you choose your keyboard mapping, language, username, password. So this is going to be probably speeded up a bit. Our first network interface is Ethernet 0. This is what we're going to use for our for the management of our host. We are also using the HCP to assign IP to this, although in production you would probably want to have a static static IP configuration. We are also going to automatically obtain host names via DHCP in our case, but again in production you would probably do that in a static way. Installation is ongoing. We're going to move to a different node, repeating basically all the steps. We are not going to install any supplemental packs at this point, and we are going to finalize the installation and finally reboot the hosts and ensure that we can access them via their assigned IP address on the management interface. Repeating the same on the second node, we are not going to install any supplemental packs at this point. And let's wait for the installation to complete on both nodes and reboot. Alright, so the installation of the first node is complete. We're going to hit OK and basically reboot the hypervisor node. We'll also hopefully very soon have the second node installed as well. First node is booting. And you can notice that our first node has booted. We have the IP address and the host name assigned by our DHCP. If you compare the IP obtained, which is here 10.0.33.9, that's exactly this IP over here, which is the IP of the first node. And let's wait for the second node to boot as well, or to actually finish the installation and yeah, to boot, which is happening right now. And our second node has also booted. You will see now it's getting its IP address and all other network configuration parameters via the HCP. So let's try to SSH into one of these just to confirm they are actually accessible. So I'm using, which is a bit weird thing from Windows, a native PowerShell to SSH. Into what's actually the second node. Alright, so the node is up and running. All right, good. So we have our two hypervisor nodes installed. So let's actually use the XCP-ng Center tool, which is the equivalent of the Zen Center tool, to actually configure networks for our hypervisors. So I'm starting the XCP-ng Center. As I said, it's equivalent of the Zen Center tool. We will connect to the first hypervisor, ensure that the networking key is configured properly, and then we will add our second node into the pool. All right, so we are connected to our first host, and you can actually, if you go to the storage tab, you can observe obviously the storage, and the interesting thing that we are actually interested in is the networking tab. So on the networking tab, conveniently, we have actually two networks which are automatically provisioned on top of NIC 0 and NIC 1. Network 0 and network 1. If you actually refer back to our diagram from before, that's exactly how we want things set up: network 0 and network 1. Now, in production environments, you would probably have multiple network cards, you would create bonds, and then you would create networks on top of those bonds. For example, NIC 0 plus 1 would be network 0, and then NICs 2 plus NICs 3 would be network 1. Or you would actually give it a more meaningful names like management and, let's say, guest, for example. Now, important thing to understand is these names of the network, as seen over here, are actually critical. So this is something we need to reference in our CloudStack. If you go back to our CloudStack installation, if you check our zones, you can notice we have two physical networks which correspond to these two, network 0 and network 1, or as visible with XCP-ng, network 0 and network 1. Now our goal is to actually, let me put these images side to side so you can follow a bit easier. Our goal is actually to have all the CloudStack management and storage traffic flow over network 0, which is network 0 over here, which is created on top of network card 0. And we want also all our guest traffic and the public traffic to flow over network 1, which is network 1 over here, and it goes actually as tagged. You will see later that the tagged networks, VLAN networks, will be provisioned based on network 1 on top of NIC 0. So let's actually just go back briefly to CloudStack. If you list our two physical networks, the first physical network holds or carries two traffic types, which is management and storage, which again corresponds to what I've written over here, management and storage. So you can see that for the Zen network label, we have set the value network 1. If you would like to, for example, update this, you could update your traffic labels and change it to something else. Now, in case this is automated environment, and usually these would be actually empty in your environment if you're running just your Zen server, so it's safe to do it like this, but we are interested again only in Zen network label. There is no dedicated storage network configured with CloudStack in our CloudStack installation, so it's you can see there is no IP ranges or anything. When we provisioned the zone, we didn't define a dedicated storage network. We said that basically we are letting it use the management network, but still we show it in the UI as two traffic types over here. And if we go back to our physical networks, the second physical network is whatever the name is actually. It carries two traffic types, which is guest and public, which again corresponds to our diagram over here. It carries guest and public. For the guest, we have a certain set of VLANs, which is defined over here. Again, as I showed in the image, 1241 until 1260. And if we go to public, you will see that we are using again a VLAN 51 with a certain start and then IP range and our gateway as shown over here. All right, so again, this is existing CloudStack installation. So you can say, for example, this is your production environment. You are having already two physical network types. You are having some clusters and you want to add new XCP-ng clusters. So basically you need to configure XCP-ng networking to match your traffic labels as defined over here. That's network 0 and that's network 1 for both guest and public. This is something that's done by default with the installation of Zen Server or XCP-ng, so basically we are good to go. I'm going to create a new pool and basically have the master server being the node number 1, and I'm also going to add additional server into this pool. So let me actually remind myself of the IP. This is 10.0.35.117. Use your login credentials that you defined when you installed your XCP-ng. And let's create a pool of 2 servers, and later we will just add them to our CloudStack and defined storage pool via NFS. I'm hitting the create pool button. It's adding members, as you can see. Certain actions are ongoing at the moment, and in a few seconds we will have our pool created. So let's give it just a couple of more seconds. You can see the status is slowly showing as different, and finally we have our pool number 1 and our 2 servers with this pool. At the moment we don't have any remote storage. That's something we will orchestrate via CloudStack. We are not going to use local storage. We are going to use a dedicated NFS from the box over here. So that being said, let's minimize. We are now basically done. The important thing is that we have our networks configured in a proper way. Now keep in mind that only on the first network you have IP address in order to be able to manage this host and this host, which is the second host, but on the second network we are just trunking VLANs to basically this network card, so to speak, or to switch port of this network card. So we don't actually assign any IP addresses for network 1. So that's important to understand. All right, going back to our CloudStack, we are going to go into clusters. We're going to add a cluster. We are saying that's a Zen server type of a cluster. Keep in mind that in CloudStack there is no difference, at least not yet, and I'm not actually aware there will be anytime soon, but there is no difference between Zen server and XCP-ng because they are binary compatible. So let's use the cluster name. This is basically arbitrary name, so let's call it cluster 1, and let's create cluster 1. This is just an entity within CloudStack. Now we haven't actually added our Zen servers yet. So if you go to host, we can actually add the first host into our cluster number 1. The host name, again, let me remind myself from this really not so nice drawing. Oops, 10.0.33.9. I'm going to log in with my credentials. And I'm going to add that host. Now, an interesting thing, the host failed to be added, so let's actually see why. All right, so this is actually a very good, let's say, example of how people can make mistakes, which is basically what I did as well during this demo. So let's cancel back from adding this host and let me go back to zones and physical networks. And again, you can see that we have traffic type where we expect the traffic label to be network 0. Notice there is no space between network and the 0. But if we go back to the XCP-ng, you will notice there is a space. So basically, the mistake I got was that unable to find storage network 0 without space for specific host which I was trying to add. So this is a very good example of how you can make mistakes. So let's briefly fix this. Let's remove the space from the name of this network. And I'll just verify it's the same for the network 1, but I'm pretty sure it is. So if we go to this different physical network and to the traffic type, yes, there is no space. Now we should be able to actually add a host. So let's do the second attempt. All right, fingers crossed. No failure yet, which is basically a good sign. Just to understand why this takes so much time, if you actually bring the management logs, I'll pause at scrolling, you will actually see that CloudStack is copying certain libraries to both Zen servers, including the second node. That's the reason why it takes so much time to actually add Zen server kind of host, which includes the XCP-ng as well. So you can see I've added the first host, but it has pulled in both hosts, which is how it actually works with Zen server. So great, we have our cluster, we have two storage hosts. If we check our XCP-ng, there is no change basically, except that there is a cloud link local network created. And now let's add a storage pool. So I'm going to go into a primary storage and add primary storage pool. In my case, it's NFS based. So basically, CloudStack will instruct hypervisors to implement or to add storage repository based on the NFS. So I know my NFS server IP, explicit path, the provider we are keeping it as default primary. I'm going to click OK now, but at the same time I'm going to actually bring up the XCP-ng Center so you can see actually this being added over here. So I'm hitting OK, and it takes a bit of time for the communication to happen, but you will see a storage pool or storage repository for that matter being created here in both basically Zen servers, or in our case XCP-ng servers. Right, so our storage is up, and actually if you check the ID of the storage 0A75, you will notice there is a storage 0A75, which is shared for the whole pool. So it's not on a host level, it's for the pool. Finally, let's enable our zone, which should trigger, in my case, I don't have yet system VMs because I destroyed all of them. When I hit OK, it should trigger creation of the system VMs, and you should be actually seeing system VMs created on one of those two hosts if everything works fine. So let's wait and give it a bit of time. you can see that I'm having 2 VMs started. If we go back to the XCP-ng Center, you will see that the first host has actually mounted the secondary storage. This is how it works. So basically CloudStack will instruct the chosen host to mount the secondary storage, and a template will be copied over to this primary storage. You can actually already see the template is basically being created. Some volumes are created and both VMs are being actually started on our hypervisor hosts, and these VMs are actually finally, well, at least from the power on point of view, running. It takes some time to reconfigure them, and after that basically we will have our VMs running. That's pretty much it when it comes to adding XCP-ng to CloudStack. And again, as I said, and I made a very good example, I could say it was on purpose, it wasn't, but it was a very good example of how the network names on the host level can affect basically adding host to CloudStack. Now, an interesting thing that's also, let's say, good to show, both of those VMs are system VMs, which means both of them have public IP address, or the IP address from the public IP range, which is the range of which you can see on the second physical network on the traffic type public. So basically we should be having an interface on VLAN 51. So if you go back to the XCP-ng Center, you can actually see that now there is a VLAN with a certain ID, well, UUID actually, a network created on top of NIC1 with VLAN 51. So, and if you go here, you can actually see that this system VM, let's say the secondary storage VM in this case, has 3 network cards. One is for the control, another is management with network 0, and the public network card is in this specific network, which is called VLAN 4DE431. If you go back, you will notice that's a VLAN interface 51 on top of network card 1. So how it works again in regards to these network interfaces, if you remember what I've mentioned here about the traffic labels, and they need to match the name of the network. Basically CloudStack will look for the network based on this name. It will find the network 1. It will extract a child interface, which is the network card 1. It will create a new network with a VLAN 51, or whatever is the VLAN defined over here in CloudStack, on top of that child interface, and then it will plug virtual network cards of this secondary storage VM, router, and so on into this new network, which was automatically provisioned. So that's how it actually works with Zen server, how the traffic label, why the traffic labels are important to be matching properly, and how actually CloudStack extracts the child interface and then creates a new network with VLAN 51 on top of that child interface. All right, good. That's pretty much all I wanted to show you with this video. I hope you get some understanding on how to configure your XCP-ng. Obviously, in production environment, you will be having many different physical network cards that you would be probably setting in either LACP mode or active-active, active-passive bond, and then create a network on top of, let's say, NIC 0 plus NIC 1, and then another network on top of NIC 2 and NIC 3, for example. And the names of these networks need to match or to be referenced properly as the traffic labels over here. I hope you enjoyed this video. See you guys next time.